Hi guys, so we're going to look at this interesting topic, which is second theorem. And as usual, before we can proceed, we're going to look at what the syllabus is demanding of us to know in this topic. Now, this is a straightforward topic that does not have a lot of subtopics. It only has two subtopics. So, second theorem is the major topic, but it only has two main subtopics. So, it only has two main subtopics. So, which are the first one is properties of a circle. So the first subtopic is properties of a circle. Then the second one is what we call angle properties. So angle properties. So these are the two major subtopics that you are going to find on this topic that we call second theorem. Now we're going to start without wasting much time. We're going to start with our lesson. So we'll start with properties of a circle. So under properties of a circle, we're going to look at the parts of a circle quickly. We look at the different parts of a circle, then we'll be able to proceed from there. So to be helpful for us, so once we look at those from those ends, then we'll be able to move like that. Now I'm going to do this. So suppose we have a circle. So suppose we have a circle like that. Now a circle has got what we call, number one, a circle has got what we call the circumference. That's the first part. So a circle has got what we call the circumference. Now, what is a circumference? For a circle, a circumference is defined as the total distance around the circle. So the distance which is around this circle is what is referred to as the circumference. So a circle also has what we call the diameter. So it has what we call the diameter. And what we mean when we say diameter, now diameter, this simply means a straight line that is drawn passing through the center of the circle. So now look at, so it's simply a line that is cutting a circle into two equal parts or two semicircles. So what the line I've drawn here is what we call the diameter. So what I've drawn is what I am going to call the diameter. A circle has got what we call an arc. So a circle has got what we call an arc. Now what is an arc? An arc is simply a part of the circumference. Now suppose this is the center of a circle, so I'm going to say center O. Then you draw a line like that from the center to the circumference. So now this part from this side to that side, then from this side to that side. So now I wanted to check it out. This part from here to there, so this part is what we call an arc. So an arc is just a part of the circumference. So that is an arc. By the way, even this side here, that is also an arc. So as long as it is a part of the circumference, not the entire circumference, but a part of the circumference is defined as an arc. Right? A circle also has what we call a radius, and by radius we mean just a distance from the center of the circle to a part of the circumference. So this distance that I've drawn here is what is called the radius. Very important. A circle has got what we call a chord. What we mean when we say a chord? A chord is just a line that is, so it's a line that is joining 2 points on the circumference. Now look at, this is a point and that is a point. So let's say, suppose these are 2 points. Suppose this is point A and point B. So this line that we've drawn that is joining these 2 points is what is referred to as a chord. So this is a chord. Then apart from a chord, we have what we call a segment. By definition, a segment is defined as the area bounded by an arc and a chord. So that's a segment. The area bounded by an arc and a chord. Now look at this. This is a chord. Then this can also be called an arc because it is a part on the circumference. So the area that is bounded by, so this area that is bounded by the chord and the arc is what is referred to as the segment. So that is the segment. So we're saying apart from an arc, we've said we have the radius. Then we have also said we have what we call a chord. We've also said we have what we call a segment. So like that. Then as part of a circle, the last part that we look at is what we call a sector. What is a sector? A sector is defined as an area bounded by 2 radii and an arc. Now look at, from this center to a part. So now one thing you should know is that the diameter is made up of 2 radii. So 2 radii, when they stretch to form a straight line, they make the diameter. So from this center to a point here, this is also a radii, and that is O. So this distance that is covered here, this area here is what we call a sector. So that is the area that we call a sector. All right. So that is very important. That is very important. Now we're going to proceed. So what we are looking at is what we've referred to as parts. So what we are just from looking at is what is called parts of a circle. So those are the different parts that a circle has. Now I want us to proceed. We're going to proceed and we're going to look at angle properties. So we're done with the parts. We're going to look at the angle properties. So now in angle properties, we're going to look at some properties that will be very helpful in answering questions on circle theorem. So these will be very important. You can call them properties or you can call them theorems. So other books would say theorems, then others would say a property. Basically they mean the same thing. So the first one, what is the first property? So the first property is as follows. So now the angle at the center is twice the angle at the circumference. What do we mean? So look at it. Suppose this is a circle like that. So that is a circle. then we have something like that in it. So then we have that, so this is the center O. So suppose this angle at the circumference is x, then we call this one as OP, then we can say R here. Then the question is that what would be the angle at the center if the angle at the circumference is x? So we're saying, according to this property, the angle at the center is twice the angle at the circumference. If at the circumference it's x, then at the center it becomes 2x. That's what it means. So in other ways, it means the angle at the circumference is half the angle at the center. Very important. So I'll pass you through all the theorems, then later on we'll look at some examples where we're going to put in what we've just learned. The second theorem is, or property, talks about angles in the same segment. So this one states that angles in the same segment are equal. Now, by now I suppose you know what a segment is. So suppose this is a circle, then this is a segment. This is a segment. Then there is an angle here that will go from that end to that end. So this is an angle from that segment. Then okay, so I can say this is angle x. Then we have another angle from the same segment going in that way and that way. So suppose we say this is angle y, and also suppose there is an other angle that is going in that direction and like that. Then this is called angle z. Now if you notice, suppose this is a segment called AB. If you notice, all these three angles, they are coming from the same segment. So we are saying angles at the same segment are the same. So therefore, angle X is the same as angle Y, which is the same as angle Z. So that is another theorem or property that you should be familiar with. We proceed with other theorems. Right. So now we look at the third theorem. So what does the third theorem? Now these are not being said in any order. Sometimes the first theorem, like I have stated in other books, it can be maybe the third or the fourth theorem. So you don't have to know them in any specific order, but you just have to know all the theorems. So the third theorem is about an angle in a semicircle. Now suppose this is an angle. So I mean this is a circle. So we'll do that. Let me do that. So this is a circle. Then what we are saying is, suppose this is the diameter. So a diameter is going to separate a circle into two equal semicircles. So now suppose inside one of the semicircles there is a triangle like that. So we can call this one as A, B, and C. So this theorem states that the angle that is formed in a semicircle is always a right angled triangle, and it is equal to 90 degrees. So look at this is how we denote a right angled triangle, and a right angled triangle is equal to 90 degrees. So that is a property about an angle in a semicircle. Very important. We're going to look at the fourth property, or we can say the fourth theorem. So I'm going to draw another circle like that. So now this one is on what we call cyclic quadrilateral. What do we know by a cyclic quadrilateral? Now, a cyclic quadrilateral is simply a quadrilateral that can be drawn inside a circle. Now, look at, we know a quadrilateral is a four-sided polygon, and suppose if it is drawn perfectly inside a circle like that, like that, like that, like that. So this is a quadrilateral. Suppose this has got angles x, then a, b, and y. So suppose those are the angles for that. So this is an angle, it's an angle, it's an angle, that's an angle. So now this one, now what do we know about angles in a cyclic quadrilateral? So this is what you should bear in mind. So the theorem is as follows. Opposite angles in a cyclic quadrilateral are supplementary. By supplementary, we simply mean they can add up to 180 degrees. What does that mean? Now look at this angle x is opposite to angle B, and angle y is opposite to angle A. So those two opposite angles, if you add them up, they should give you 180 degrees. What it means, if I say x plus b, I should get 180 degrees. If I say y plus a, I should get 180 degrees. So that is what the theorem states. Very important. Okay, so that was the fourth one. We're going to proceed. We look at other theorems and see how we can go about it. All right. So now let's look at the fifth theorem. So theorem number 5 is a theorem that is going to talk about tangents. So now suppose this is a circle, then there is a tangent. A tangent is a line that is going to touch a part of the circumference. So this is a tangent. It's supposed to be a straight line. So we can call this one as A, B, C. Alright, so what do we know about a tangent? Now, let's say there is a radius here. This is a center. So now, one thing you should know about a tangent is that the radius of a circle is perpendicular to a tangent at the point of contact. Now look at, this is a radius, then this is a tangent. Once they come in contact, they form a 90 degrees. So the tangent and the radius are perpendicular at the point of contact. That's the first property on tangents. So we call it theorem number 5 on tangents. Then there is another theorem on tangents. Another theorem on tangents. Suppose we have a circle like that, then we have a point. So this is the origin. Then from this origin, there goes a tangent, and from the same origin, another tangent goes in that direction. Then this is the center. We know at the point of contact, they're going to form a 90 degrees. Again, on the other end, at the point of contact, they're going to form a 90 degrees. This is the origin. All right. Then let me separate it like that. Yes. So now, what should you know about such kind of a drawing? So now, if there are we have two tangents that have been drawn from an external point to a circle, this simply means their lengths are the same. So now look at, this is an external point. All the two tangents are coming from this point. So the theorem is that two tangents drawn from an external point have got the same length. This simply means the length of this is the same as the length of that tangent. They're very much important. You have to know that. Now, what do we say? If the length is the same, it means the angles should also be the same. So this simply means this angle and this angle should be the same. So this is 90, this is 90, so they should add up to 180 degrees. Okay, so that one is very important. Alright, so if these two are adding up to 180, then it simply means this angle here and the angle at the center, they should also add up to 180 degrees, because we are looking at a quadrilateral. So that is the theorem that we have there. Then we're going to proceed. We look at, we see if we have other theorems that we can consider looking at. All right. All right. So now, at this particular time, we're going to look at, we ended on theorem number 6. So let's see theorem number 7. Now, theorem number 7, we're going to look at this. So suppose we have a circle like that, then we have a tangent. Okay, it's not perfectly drawn. Let me just remove that. Okay, so we have a circle, then we have a tangent drawn like that. Then inside the circle we have a triangle inscribed like that. So suppose this angle is x. Now suppose we have another angle here that we can call angle y. So what should we know about this property? Now this is what I want you to know. We have something like that. So if a chord, now let's look at it. This is a chord from this point to that point, that is a chord. Even from that point to that point, it is a chord. From that point to that point, it is also a chord. So a chord is drawn. So now the exterior angle should be equal to the opposite interior angle. So that is the point that I'm trying to emphasize here. We have a tangent here, right? Then we have an angle here that is opposite. So this is an exterior. So this angle is an exterior angle. And this other angle here is an interior angle. So the exterior angle should be equal to the interior angle. So once that chord is in contact with the tangent, so if a chord is drawn, then once that chord touches the tangent, we are saying the exterior angle that is made should be equal to the opposite interior angle. Right, so this can be called an alternate segment. So it forms what we call an alternate segment. So this simply means x should be equal to y. Very important. So that's it with the properties. Now we're going to look at some examples we can see. Then we see how best we can handle them. Then I'm going, as usual, I'm going to give you some questions that you can try and see how best you can go about them. All right, so we'll start with an example that you can try looking at. Okay. Right, so suppose we have a diagram, and that diagram is as follows. So this is a circle. That is a circle. Then I draw a chord like that. Then we have that. We have that. Then we have that. Then we have that one like that. Okay. Then from there, I'm going to say we have that. Then we have that. Okay, that is what we have. Then I'm going to name them. So let me say also from here we have something like this. So let's say we have that. Then we have that. So this one I'm going to say it's O. Then suppose there's an angle here. So if this is an angle, and the size of this angle is 100 degrees. Okay, so suppose this one is A, this one is B, then we have C there, then we say D this side, then E that side. Then now, let's say, then we've been asked now to find the first question. Let's say we find the angle CBD. So the angle CBD. So if they do that, it means they're looking for the angle at B. So you look at C, then B, then D. So we're looking at the angle at B, this angle here. So now we always go for the angle which is at the middle. So the angle at B. Now the angle at B is an angle at the circumference. Then if you remember, we already have an angle here at the center, and this angle is 100 degrees. What did we say about such kind of a theorem? We said an angle at the circumference is twice the angle at the center. Suppose the angle at the circumference is x degrees. Then the angle at the center is what? Is 100 degrees. You see that? So now, if we say twice of x should be equal to 100. So what we mean is that if I say 2x should be equal to 100. Then you say divide by 2, divide by 2. That goes, then x will be equal to 50 degrees. So that is the angle at CBD. So what this simply means is that without wasting much of our time, we see that here we don't have an angle. Here we've been given 100 degrees. We know to say if this angle is twice this angle, then the angle at B is half the angle at the center. So you just get half of 100. And half of 100 is what? Is 50. So that is the 50 degrees that we have found there. Then we proceed and look at another question. Okay, so suppose we are also asked to find, let's say, CED. How can you find CED? So the angle at E. So we're looking for the angle at E, this one. How can we find that angle? Now look at, if you look at this diagram, there is a point here, there is a point here, number 2, number 3, then number 4. So this is going to form what we call a cyclic quadrilateral. Now I want to use a different color so I to be able to see the cyclic quadrilateral that I'm talking about. So this is the cyclic quadrilateral. It's a four-sided polygon. Four-sided polygon. So that is the cyclic quadrilateral that I'm talking about. And from a cyclic quadrilateral, we say the opposite angles should add up to 180. And this angle already, we have found that that angle is 50 degrees. Then what do you think will be the size of the other angle? So basically we just say 180 subtract 50. Then 180 subtract 50, what we get? We get 130 degrees. So that's basically how you can solve that. Alright, then let me put the last question, number 3, on this one. Suppose you've been asked to find angle CAD. So the angle at A. Angle CAD, this angle, we're going to look at the property of segments. Now, remember, so if I may pick a different color too, so this is a segment here, this is a segment, and from this segment there is an angle that is coming out, which is that one. From the same segment there is an angle that is coming out, that is going out, which is that angle here. So this angle and this angle are coming from the same segment. So what did we say? We said angles from the same segment are always equal. So angles from the same segment are always equal. You can check through the properties and you find it. So what are we going to say? So here we're saying angle CAD should be equal to angle CBD. So, and what is the size of that angle? So the angle is 50 degrees. The angle is 50 degrees. So that is how you can answer those questions. I'm going to put in another question again that we can try out. So we looked at angles in a segment. On the same segment, we've looked at angles at the center. Alright, we've also looked at opposite angles of a cyclic quadrilateral. So I want to see if I can try to put in a question that would demand a different theorem. Okay, suppose we have a second question. Let me just put one question. This is a circle. Then we have a diameter like that. So this is the center O. Then we have something like that. So suppose this has been given to us as 3x, the angle. Then this angle has been given to us as 60. So we have 3x and 60. Then we can say this is A, this is B, this is C. Then now we are asked to find the value of x. Then the question is now saying find x. How can you find x in such a situation? It's easier to find the value of x because this is what we're going to do. This is a diameter, and the diameter is cutting the circle into two semicircles. Then remember, from one of the theorems, we said the angle in the semicircle is a 90 degrees. So look at this angle here. Even if we don't know it, we know now to say it's a 90 degrees because of the theorem. So this angle here is a 90 degrees. So therefore, if I say angle 3x plus angle 60 plus angle 90, this should give me 180 because we are looking at a triangle. Then this would be 3x, then 60 plus 90, I'll get 150, then this should give me 180. So if I subtract 150 from both sides, I'm going to have 3x is equal to 180 minus 50, we get 30. Divided by 3, that goes, then the value of x remains 10 degrees. So the value of x is 10 degrees. That is how you can go about that one. So that one talks about angles, the angle in a semicircle. So that one is just straightforward. That is how you can handle that one. Alright, so basically you can use those properties to answer different questions that might come. Now, in the interest of time, you just have to practice using different examples. I'm going to give you some questions that I want you to try. Then once you try, you can check in the solutions you're going to have. Then I can check them out. I can mark them. So now I'll give you a task that you can try to answer. So the first one, so I'll draw a circle. Then the circle that I'm going to draw, I'm going to put okay, what am I want to put in something a bit different, but you'll be able to answer it because we've looked at all the properties. So whatever I'm going to put in there, you'll be able to answer because we've looked at all the properties. So suppose we have that, so let me put it there, so something like that. Then from there we have something like that. Then from there we have something like that. Then from there we have that. Alright, then here I'm going to say we have something like that. Okay, then suppose the center is somewhere there, then we can have that and we can have that. So all these are coming from there. Then there is an angle here, so I can be writing the angles in a different color. So there's an angle here of 124, so that one is angle 124. Then there is another angle here which is angle 36. So I can name this one as my A, this one as my B, then you can say C there, D, then this is a center. Then from there you've been asked to find, I want you to find the following angles. So the first one, you should try find DCB. So find angle DCB. So DCB. So you try to find this angle. Then the second one, Roman numeral 2, you try to find angle DAB. So you try to find angle DAB. Then Roman numeral 3, you try to find angle ODB. So angle ODB. Alright, then the last one, Roman numeral 4, you try to find angle CBO. So angle CB, then O, you try to find that. Then I'll put in a last question so that you can have more practice. So the last question. Now the question that I can put in is right, just one last question. Alright, so suppose we have something like this, like that. Then we have a tangent there. Then we have okay, I can put a cyclic quadrilateral inside. Cyclic quadrilateral inside. Then from there, okay, suppose like that, we have our center somewhere there, so this is center O. Then we have this that is coming to touch that part. Okay, then we have okay, let me put in an angle there. So the angles will be, so let me first name these. So let's say this is C, then if that is C, I want my A to be there, then I want my B to be there, C, then I want my D to be there. Alright, then from that origin, so let me do that. Just a minute. So I want a line that will come and cut through here. So this is O. That's where the origin is. That's where the center is, I mean. Alright, then let me put in some okay, let me name this. Okay, I just say I put in some angles using a different color. So suppose there is an angle here, and that angle is 30 degrees, and I also want to put a different angle. So let's say there is an angle where, right, so alright, so this one, okay, let me just okay, there is let me just remove this so that I can just draw it. I want it to come out in a certain way. Okay, so let me pick it up from here. I want it to come out in a certain way because there is a property that I'm interested in that you should be able to find. So let me do that. Then from there, this now can come like that. Okay, I think like this, it's making some sense. Then I just get back that. So from here, an angle that is coming to pass through that, then the 30 still maintains. So this is where the 30 is, and that's where the origin is. Then we have that. Then now in proceeding, let me say there's an angle here. So let me put an angle. There is an angle here, and that angle is a 40 degrees. Then the question, you're supposed to find, so A, you find angle CBD. So where is C? C is there, B is there, D is there. Okay, angle CBD. Then you also find part B. I want you to find angle BAC. Okay, B is there, A is there, then C is there. Then part C, I want you to find angle AOB. So angle AOB. So that angle. So those are the questions that I want you to try. I think that would be better. Okay, so you try them, then you send, and we see how best you can do them. Thank you.